first thing that we're going to look at is the formula for density. So the formula for density would be mass over volume. So we're going to keep that in mind. We've seen it in our notes. And then this is going to be usually most likely be at the top of all of my pages because I just have the triangle. So I know that the different volume is mass over density and density is density times volume. So the first one that we're going to do is 2. So the problem reads, calculate the density of a 300-gram substance when this substance is placed into a graduated cylinder. The water level raised from 12 milliliters to 132 milliliters. So we don't know the density because, of course, we're calculating the density. They've told us that the mass is 300 grams and then the volume is 120 because 132 minus 12 is 120 milliliters. So the formula for density is mass over volume. So we're just going to put the mass, which is 300, and the volume, which is 120 on the bottom, and then you get the 2.5 G over centimeters cubed. The next one we're going to do is 4. So the problem reads, 17 grams of a substance had a density of 8.5 grams over milliliters. If this substance was placed into a graduated cylinder that had 12 milliliters of water inside initially, what would the final level of water be inside the graduated cylinder after the substance was placed in? So again, we're going to go over what we know. Boom, density is 8.5 G over milliliters. Now, how do we know that? Because it said it in the problem. It's a given. The mass was 17 G. They gave us the 17 G. And then we're trying to figure out what the volume was. So the formula for volume is mass over density. So we put the 17, which is the mass, over the 8.5 G over milliliters, which is the density. And we get 2. So then we're not done yet. They're asking what's the final level of the water. So we're going to have to add 212, and that's how we get the 14 milliliters to know what the final is because it initially started with 12. Our next one we're going to do, I'm going to skip 6 because I'm going to work that one out on a different sheet of paper just so you can see it. Number 8. If a 24.5 centigram stone of titanium is placed into a graduated cylinder, how much would the water level rise? So again, let's go over what we know. Density is 4.5 centimeters. Now you might say, how did I get that? Because that's not in the problem. Well, we're going to go to our density reference tables, and it says right here that titanium is 4.5. So that is where I got that number. So it's 4.5 grams over centimeters cubed. Our mass, as they give us, is 24.5 centigrams, and then we need to find out the volume. And to find out the volume, our equation is mass over density. Now we need grams, not centigrams. So we're going to do the King Henry died by drinking chocolate milk, as in our notes, just to show you where we got this from. We did the King Henry died by drinking chocolate milk. So we're just going to go back to our problem. Okay, so because we had to do that, we moved the decimal 1, 2 places. So we're going to take the decimal, move in the same direction, 1, 2. So it would be, I'm sorry, I forgot my point there, 0.245 grams over 4.5 because that is our density and that's our formula. So after we do that, we got 0.054 milliliters, and that's how we did that one. We're going to go to 10, the next one. So the problem reads, actually this is on a different sheet of paper because it was last, so I'm going to show you the work on there. But the problem reads, 4 pieces of nickels were placed into a gradual cylinder, causing the water level to rise from 22 milliliters to 122 milliliters. If the first piece is twice the size of the second, and the second is 4 times the mass of the third, and the fourth is half of the mass of the third, determine the mass of the third piece of nickel. So first, what we have to do is we have to determine the mass, the total mass. So when we determine the total mass, or looking at this one down here, let me fold it. So when we look at the total mass, we had to do 8. Obviously, we're looking for mass, and the equation for mass is density times volume. So we had to do 8.9, which is the density, grams obviously over centimeters cubed, times 100, which would have gave us 890. So our first one, we have to go through the problem and determine which one is the smallest one so we can use that one as x. Obviously, we've determined that the fourth one is the smallest, okay? So I'm going to go backwards because I used the fourth one, so it's easier to work up. So the fourth one is half the mass of the third. If it's half the mass of the third, we're going to have to multiply that by 2, which will make that 2x. Then the third piece, the second piece, is 4 times the mass of the third. So 4 times 2.